We'll now talk about how we would go about implementing stacks. As we said before, a stack is a list. So what that means is we can use any list implementation to implement our stack. So this means that we could use either the array list or linked list classes. Either one is going to be fine. Now there may be some rare circumstances where we want to create our own special purpose implementation, but quite frankly, we can just use either list implementation. We don't need to come up with a custom version for the stack, but you can if you want to, but either array list or linked list will work perfectly fine. In fact, both of the main operations, push and pop, would take constant time because we're inserting or removing at the end of the list. We're not going to see any major difference in execution with one implementation or the other because we're just dealing with the end of the list. So both inserting and deleting would be constant time operations. The question we should be asking, though, is if we're given the array list or linked list classes, do we need to make any changes to those? Well, the answer is yes and no. The logic is simpler, so we don't need all of the other functionality that's provided by the implementation. So we are only having to insert and delete at the end of the list. We don't have to worry about insert and delete at the front or at some arbitrary place. So we could make changes to those implementations, but usually we don't want to do that. We talked about before about how we don't want to modify something that's already there. We can create our own class that gives us what we want. So what we can do instead is we'll create a stack class that's going to call the appropriate methods in either implementation. So we're going to have several classes here to make this work, but that's fine. We're going to have our client that's going to call stuff from a stack class, and this stack class is going to have all the functionality specifically for a stack, but it's going to call the appropriate operations in either the array list or the linked list implementations. We'll start by looking at how we would implement this using a linked list. So we only need a singly linked list. We don't need a doubly linked list for this. And because we will be using the linked list class, so we'll still use it, we just need to make sure that we don't go backwards. We're still going to go forwards, that's okay. We just have to make sure that we're not go backwards. So we can still have a doubly linked list as the underlying data structure. We just don't use any of the functionality of going in the opposite direction. The way we'll handle the push operation is we'll insert at the front of the linked list, and then for the pop operation, we will delete the element at the front of the linked list. And then our top operation is just going to look at the element at the front of the list and return the value of that node. In some cases, or at least in some implementations, both the top and pop operations can be combined into one operation. It just depends on how you want to implement it. Here's the code for implementing the stack using the myLinkedList class. So we're going to call our class myStack, and notice that just like with our lists, we can specify what the type is whenever we create an object of this. So this could be a stack of integers and doubles and so forth. We see that we have two instance variables. We have a reference variable for the myLinkedList class. So what we're going to see is we're going to create an object of that class in just a little bit. And then we also have a variable for top. So this will let us know exactly where we're currently at in the linked list, or I should say where is the top of our stack, which should always be pointing at the very top of the list, the most recently added item. We have a constructor for the class. So here we're going to create the object of myLinkedList. And notice that we're going to initialize our top variable to -1. This is intentional because what we see in our push operation when we call the respective add method in the myLinkedList class, we're going to increment top first, and then we're going to insert that spot. It actually makes it easier to deal with the top variable if we initialize it to -1, increment, and then insert. That way, when this is done, top is pointing at the current top of the stack. And then here are the remaining methods in the stack class. So our pop method is first going to make sure that there is something in the stack. If there isn't, then we're going to throw the no such element exception because the stack is empty. And if there is something in there, we're going to call the remove method from our linked list. So we're going to remove the current top item And then notice that when we're done, we're going to decrease the value of top because we need to change where the top of the stack is. And then for our top method, well, we first have to check to make sure there's something there. If there isn't, then we're going to throw the no such element exception. And then if there is something there, then we're going to use the get method from our linked list class to get the value of the current top item in our stack. And then of course we have our implementation of the isEmpty method, which is just going to call the isEmpty method from the list. We'll now talk about how we can do this using arrays. And the good news is we can actually use the exact same implementation for arrays. The only difference is we would use the myArrayList class instead of the myLinkedList class. So here's an interesting question. What if we wanted to use our own implementation? We can use the myArrayList class. That's fine. I'll show you the code on how we would do it, and you'll see it's not really any different from the myLinkedList class. But what if we just wanted to create our own custom implementation using arrays? So think about that for a second. Well, the reason why I ask you this question is because an array is a more popular approach for implementing stacks compared to linked lists. Why? I think it's just because it's easier to work with, especially with the index, since we can directly decide which element we're going to add to and remove from. So if we were going to just use arrays directly, we would still have our array and top variables. Our top would be initialized to -1. That way we would know that we have an empty stack. This is another reason why we can't have top be 0, because with arrays, there is an index 0, but with the top here with our stack, we can use -1 to say we have an empty array, and then we would go to 0 if we want to put something in that first element in the array. Now, if we wanted to push an element into the array, or I should say the stack, and we'll call this element X, what we would do is we would increment the value of top, and then we would just set array top to be X. And then if we wanted to pop, well, we would just set the return value to whatever array top is, and then just decrease the value of top. That's it. Here is our code for implementing a stack using arrays. And what you'll see here is it's pretty much identical to that of the linked list approach. There are just a couple little differences. So we're still using myStack as the name of the class. And our list reference variable is now going to be of type myArrayList. So we see that this is the type right here. Let me draw this a little bit better. There we go. So this is of type myArrayList instead of myLinkedList. In the constructor, we would see that we're just going to call the myArrayList constructor. So that's what we're doing here. Top is still -1. And then when we're pushing, we're still calling the same add method. It's really no different from what we saw before in our stack implementation. And then here is the code for the remainder of our stack class. And if you look over here, it doesn't look any different from the linked list approach. We look at our pop method and we check to make sure that there is something in there before we remove. If there is something, we will call the remove method from the list object. We look at the top method, it does the same thing. We check to make sure there's something there. If there is something, then we will get the value of that top spot. And then we still have the isEmpty method, which is going to call the isEmpty method from the list object. Now what we're going to do is, since we've talked about implementing these stacks using both arrays and linked list, we'll go ahead and implement a client program to actually push elements onto a stack and pop them and print the stuff. Now we'll use the linked list code approach, the linked list implementation. So I have my myLinkedList class here that we've seen before, and then I have the mystack.java code using the linked list implementation that we just talked about. So we're going to call this mystack. Once again, we can specify the type that we want to contain in the stack. We have our linked list, we have our top, we have our constructor that initializes instantiates a new object of my linked list. We have our push method, which is going to call the add method. We have our pop method that's going to check to see if the list is empty, and then we're going to call remove. We have our top method, we have our isEmpty. So we have everything here. So now we can just create a client that would actually put stuff onto a stack. So we'll create a new program and we'll import java.util package just to be safe. And then we'll do public class. We'll call it myStackClient. And we need to add our main method. So the first thing we're going to do is create an object of our stack class. And let's say we're doing a stack of integers. So we'll do myStack and then integer. We'll call this myStack. Let's do new myStack integer. So now I can just add elements. I can push them. So we'll use the push method for it. So we'll do myStack.push. So we'll do something like push 5. Let's do a couple. Push 10, stack push 15, then stack push 20. And then what we'll do is we'll pop and print the contents of our stack. So we'll do while myStack.isEmpty. So this is just saying as long as the stack is not empty, we'll do a print. And we'll use the pop method here. Because remember, this will also give us the value that we just popped. So we'll print everything on a single line. So what this should do is we'll push the 5, the 10, the 15, and the 20. And then we're going to pop and print. So it should print 20, 15, 10, and 5. That's what it should do. So let's compile this to make sure everything works. And we need to save it. So we'll save it. Compilation completed, no compile errors. So let's go and run and see what happens. So sure enough, it does print 20, 15, 10, and 5. So we did push stuff onto the stack. We did pop stuff and print what we had. So this gives us a very simple client for the stack. And here I really want to emphasize, if you take a look at this and I ask you, what's the data structure being used? You couldn't tell me. Is there anything here that says we're using an array or using a linked list? Well, okay, well, this right here tells us we're using a linked list, but let's just say you're looking at just the code. There's nothing here that tells us that. That's the beauty about the object-oriented design that we're trying to achieve here. That's the beauty about using classes and objects and doing all this. We have this lovely interface with the myStack.java. I shouldn't say interface because it is implemented. It's an implementation of all these different methods, but all the client needs to worry about is just calling the appropriate methods, and the user doesn't have to worry about how it's being done. The user just knows that push is going to add something to the stack, is empty is going to check to see if the stack is empty, and pop is going to remove the top item from the stack.